everyone, I am Quinn and I will be continuing from our last lesson. We went over linear graphs and I would like to cover the number pattern adjacent of a linear graph, which is better known as arithmetic number pattern. The arithmetic number pattern comes in the following form, which is a plus t, a plus 2d. It usually comes in this form, with a being our first term in the number pattern, and d being our constant difference. Now, a similarity you will instantly see is that this arithmetic number pattern is very similar to our linear graph or linear equation with some restrictions. In this case, our gradient or rate of change or derivative is our constant difference, and instead of using any real number on the x-axis, meaning we can go from negative infinity to infinity, so we start at 1 always. With our number patterns, we always start at 1. Now, your arithmetic number pattern, the general equation, will come in the following form. It will come in a plus n minus 1 d. Now, we've already stated our a is our first term in the series, and d is our constant difference. Now, what is n? N in this case is the same as our x. So, our input. Think of it as our input, basically. We input a number and we will receive our output. Like in the spider diagram I showed you in the last video. An example of a linear pattern, for example, is the following. Seven, 2, negative 3. With our ends being so our n is equals to the following terms. And our output is 7. So if we insert 1 into the graph, we will receive 7. If we insert 2 into the graph, we will receive 2. And if we insert 3 into the graph, we will receive negative 3. Remember, one of the most important things is that n has to be greater than 0, and n has to be a real number. A whole number, essentially. So we can't have fractions in number patterns. We just can't. They have to be whole numbers. So to find the difference of this number pattern, we minus the second term by the first term. So to find d is equals to t2 minus t1. And our answer here would be 2 minus 7. And that is equals to negative 5. So now we know our d is negative 5. We sub it in. We have our a, we have our d, so we can fill in our equation. Our equation is equals to our general term, which is tn, is equals to a, which is our first term, which is 7, plus, open brackets, n minus 1, and our d, as we've just figured out, is negative 5. And that would be our general term. Another section that is important in arithmetic number patterns is understanding how to calculate the total sum. The formula for total sum is one of the two following. The simplest formula, but it has its restrictions, would be Sn is equals to n over 2 a in brackets, keep this in brackets. I think it's better if I write it out in marker. So our equation is n over 2 n over 2 open brackets a plus l a being our first term, n being our input, and l being the last term given. The restriction of this formula is that you can only apply this sum formula if you know what the last term is. So in this case, we only have 3 terms, and our last term is negative 3. So we would sub in negative 3 right here. But in cases where it is ever continuous, we cannot use this formula. Once we have understood that it's ever continuous, we use this formula instead. This formula has no restrictions whatsoever, so you can use it under any circumstances as long as the number pattern in question is a arithmetic number pattern. And that equation is n over 2 open brackets. We have a plus open brackets n minus 1 d. So this equation here has no restrictions, and as we've already stated, a is our first term, n is your input, so your 1, 2, 3, 4, 5, 6, 7, 8, and d is your constant difference, or in linear functions, your gradient or rate of change. Now for these guys, we usually receive questions like, find the first 40 terms of this arithmetic sequence. And they usually come in the following forms of, let's just make one up, negative 15, negative 9, negative 3, plus 3, plus infinity. So that essentially just means we're continuing to infinity. Now, question is asking, find the first 40 terms. We do not have the last term, so it already cancels out this formula, meaning we have to use this one. Our Sn is 40, since we have 40 terms. So we write down the following. We'll have our n is equals to, n is equals to 40. Your a is equals to negative 15. And your d is equals to 6. d is equal to 6. Then all we do from here is sub into the question. So it would be S14 is equals to 40 over 2 open bracket into 2, our a is negative 15, plus our n is 40, 40 minus 1, our d is 6, and we close the big bracket. So S40 is equals to quickly type this into your calculators, and the answer you should get is 4080. Done. I will post some examples on the channel for number patterns. I will gradually go through easier questions and then later post harder questions. But this would make the end of our lesson. I thank you for joining me. Next, we will continue with quadratic function and the quadratic number pattern. Thank you for your day and your time.